Now, obtuse trigonometric ratios are the sine, cosine, and tangent values of angles between 90 and 180 degrees, where sine remains positive, but cosine and tangent can be negative depending on the quadrant. Here are the equations that we use to calculate sine, cosine, and tangent when we were given angles greater than 90, right down here, this little thing. And so first, for sine of theta, when theta is greater than 90, we would take sine of 180 minus theta is equal to sine theta. And then for cosine, similarly, we would take cosine of 180 minus theta is equal to cosine theta. However, for cosine, there is a negative out in front, as you see right here. And then just as cosine, tangent is tan theta is equal to the negative of tan of 180 minus theta, as you can see here. Now that you have a foundational understanding of the equations for obtuse trigonometric ratios, I'm going to show you the unit circle that I mentioned earlier, which is essential to trigonometric concepts, as they inform many of the basic sine and cosine values. Okay, here's a visual representation of the unit circle. Credit to mometrics.com for this image. And so the unit circle is a circle with the radius of 1 centered at the origin of a coordinate plane used to define sine and cosine at the y and x coordinates of a point on the circle. It helps extend trigonometric functions to all angles, including negative and obtuse ones, not just 30, 45, 60. This circle corresponds to the x and y planes, and each value for sine and cosine demonstrates how sine and cosines behave separately on a graph, so they're individual functions. And then by memorizing this unit circle, you can solve problems using obtuse trigonometric ratios much easier because you know the value of things like sine 30 or cosine 60 or cosine 150. There are a couple intricacies, however, to the unit circle that I'm going to review right now. First and foremost, there are quadrants on the unit circle denoted as 1, 2, 3, and 4. You'll often see them as Roman numerals, but all you really have to know is that they're 1, 2, 3, and 4. And each quadrant has signs associated with it, meaning if you ever obtain an angle of 210 degrees for cosine, your answer should be negative because it's in the quadrant where the values of cosine are negative. Similarly, if you find yourself having an angle of 225 for sine, your answer will also be negative because if you see here, sine is negative. And then what's different is that in quadrant 4, cosine is positive where sine is negative, and then similarly inversed, the second quadrant, cosine is negative and sine is positive. Another key concept is that fraction values that are in parentheses, as you can see like right here, they represent ratios at cosine and sine. More clearly, when you see 1/2 root over 2 at 60 degrees, this is indicating that when theta is 60 degrees in a right triangle, the cosine value of 60 is equal to 1/2 right here. And the sine value is equal to root 3 over 2. And it's always going to follow the format of cosine, comma, sine for these ratios. So that's definitely something to remember. Finally, what we learned about 30, 60, 90 triangles is going to be important here because you'll note that most of the angles on this unit circle that are highlighted are 60 and 30 variations. On the unit circle, because the default x is equivalent to 1, which makes the default adjacent 1, the hypotenuse 2, and the opposite root 3. From these values, we can use the definition of sine, cosine, and tangent to find their values on the unit circle. Essentially, these ratios make up the core of the unit circle. So the reason it's 1/2 for sine at 30 degrees is because the opposite over the hypotenuse at 30 degrees is 1 over 2, just like with those ratios. And that's how we even figured out the unit circle in the first place, is because of those core 30, 60, 90 ratio numbers. And I only mention this because it's going to enhance your understanding of the unit circle to know where these fractions come from. But it's also possible to just memorize the unit circle, which really negates the reason for you to understand why. And I would recommend memorizing the unit circle and understanding where these numbers come from. But at the end of the day, all you really need to know is that they do exist and what they are. Hopefully that makes some sense as you continue to familiarize yourself with this unit circle. Things will become easier to understand as long as you do more questions. So if you're confused right now, it'll make sense with time. And by using the unit circle as an aid during the next problems, it will definitely help you to understand it better. So I would recommend pulling up a unit circle and doing the practice problems with it. You can see there's the degrees and then there's the fractions, but then there's also this strange number with pi in it. This is a additional slide with a very simple explanation for you to understand, which is radians versus degrees really quickly. If you noticed on this unit circle is a radian. So radians are based on arc length and they use the pi symbol, while the degrees show how obtuse or how acute an angle is. Radians measure the outside of a circle, but they essentially are the same thing. And by converting between radians and degrees, you can use sine and cosine functions no matter which unit you're working with. So I would just remember these two equations, which is how you convert between the two of them. And this helps you switch between the two systems and still get the correct and sine cosine values from the unit circle, which is going to be really important in the future. Okay, now I'm going to give you an example question for obtuse trigonometric ratios so you can go and solve some on your own. For this example question, it's asking us to find the sine of the obtuse angle 120 without using a calculator. First, we should set up the equation to make sine of 120 equal to a sine of 180 minus sine 120, just as they gave us in the examples before. And then by doing math, you will see that this means that the sine of 120 is equal to the sine of 60, which is fairly easy to figure out with our unit circle and with additional. And if you understand the 30, 60, 90 ratios, you can figure it out that way. And you would find that sine of 60 is equal to root 3 over 2. Now that you've had an example to help you, you should move on to the next problems and do them in a similar way right here. And I'll go explain it in a second. Okay, now that you've solved these questions, I'm going to review them with you. First, on question 1, I asked you to find the cosine of 150. Now, what I did to solve this question was I set up the equation as it was given to me, setting cosine of 120 equal to the negative cosine of 180 minus 150. And in doing this, you will see that this gives us cosine of 150 is equal to the negative cosine of 30, which using the unit circle, we can see is root 3 over 2. Therefore, the cosine of 150 is equal to the negative is equal to negative root 3 over 2, which can be fact checked again by the circle by looking that cosine of 150 is in fact negative root 3 over 2. Next, question 2 is slightly trickier because the question is phrased in radians rather than degrees, but using the equations we just learned, you can convert into degrees pretty easily. So just to remember, pi is equal to 180 degrees. So if you multiply what 180 by the number that you've multiplied a pi by, which is 76, that's going to give you 210, which would make the degrees associated with 7 pi over 6, 210 degrees. And now that we have our degrees, we can go into setting up the equation the same way. No, this is a little bit different because 210 is in fact greater than 180. So if we had subtract 180 by 210, we would end up with negative degrees, which is impossible because that would be like an inverted triangle. So to correct this, instead of making it 180 minus 210, you see that there is 180 degrees in 210 and set sine of 200 equal to sine of 180 plus 30. And since this is going against the formula we were given, you're going to move a negative sign outside of sine of 30 later on because our original equation was sine of 180 minus of a theta value. So that's why we've moved this sign out. But otherwise, it's going to stay the same. And once you have the sine of 30, you're going to solve that and it's going to give you 1/2. And then with that negative symbol, it's going to give you negative 1/2. So our answer is sine of 210 is equal to negative 1/2. Hopefully this question went well for you. I understand it was a bit of a jump between the two questions, but I tried to make it hard enough that you might see it on the exam, but easy enough that you could still go from my original example. Okay, finally, now here are the key takeaways for obtuse trigonometric ratios. I would say the most important advice I could give you is to take time and memorize the unit circle, as it is essential to most trigonometry. Additionally, remember to convert to degrees and consider the quadrant you're operating in. This is going to be a big kicker for a lot of people mathematically. You're going to have some odd negative signs and positive signs if you don't think about the quadrant you're in.